Hello everyone. Today we are going to solve a question on nodal analysis. So this is the circuit given. So there is one voltage source and as well as one current source. The question given is like this. So this is a current source given, which is 20 volts. This is given as 10 ohms. This is given as 3 ohms. This is given as 6 ohms. This is given as 5 ohms. And this is given as 2 amperes. So basically, how many nodes are there? There are two nodes. This is the first node. Let me name it as V1. So what is a node basically? Where two or more than two circuit elements meet. But this is nothing but called as principal node. It is a node where three or more than three circuit elements meet. So this is V1. And here it is V2. And let us take this as a reference. So let me just quickly write this as V reference. So this is the reference node. Now, if you see, this is the 2 ampere current given and the arrow indicated it like this. So current is entering like this. It will go like this and like this. So for what you are going to apply here, we are going to apply KCL at node 1. Apply KCL at node 1. So what does KCL state? I is equals to V by R. So if you see, the current given is 2. So 2 is equal to, this is the current source, that's why we are writing 2. So entering currents is equal to leaving currents. No, so 2 is equal to, let me name it as I1 and let me name this as I2. So I can write 2 is equal to I1 plus I2. 2 is equals to I1 plus I2. So entering currents is equal to leaving current. So 2 will be as it is. What is I1? I1 is, what is I1? I1 is V1 by 5. What is the formula for I? I is equals to V by R. So what is the voltage? Voltage is V1. V1 by, what is the resistance connected to V1? It is 5. So V1 plus 5 and V1 is going towards V2. So I will write V1 minus V2 divided by 6. This is your equation 1. If you simplify this equation, you will get 2 is equal to, take V1 common, you will get 1 by 5 plus 1 by 6 minus V2 you take common, you will get 1 by 6. So this is your equation 1. Right. So just erase this. Now, your same thing what you are going to do, you are going to apply KCL at node 2. If you apply at node 2, what you will get? If you see, I can assume that current is going from, you can assume current is leaving this node, V2. So I'll assume the current is leaving. So apply Kirchoffs current law at node 2. What you will get? So if you apply Kirchhoff's current law, see, it is your wish. You can take current is entering from 20, or you can assume that our current is always leaving from the node. As the current is given from 2 ampere, that's why we are assuming it as entering current. So let me just quickly apply. So V2 is going towards 20. So I will write V2 minus 20 divided by, what is the resistance in between V2 and 20? It is 10 plus V2 by 3. V2 by 3 plus V2 minus V1 by 6. V2 minus V1 by 6 is equal to 0. Okay, if you take V2 common, what you will get? You will get 1 by 10, 1 by 3, 1 by 6. And this will be minus 20. I'm just splitting it. It would be minus 20 by 10 and it will be plus. If you, not plus, it's minus. If you take V1 common, minus V1 if you take common, you will get 1 by 6 is equal to 0. So using calculator, if you solve mode, equation and 5, if you press and you press 1. So what you will get the value of V1 is equals to, and you will get the value of V2 is equal to. So V1 you are approximately getting 7.9 volt and V2 you are getting 5.55 volt. You cross verify this. Thank you.